I know. I didn't start it actually yet, but on that one.
Uno.
And now I got you a little late on that, guys.
Well, we gotta adjust time.
Yeah.
All right. So we factor out an x in this case. And then this inside, a little bit strange. Hopefully you guys remember that if it's x to the fourth, you can just really treat it like an x squared. And we want to multiply to get 1, but add to get negative 2. So what is it going to be? Minus 1 and minus 1. So obviously we have 0 here. You can factor this or solve it by square root. What do you guys want to do? Factor?
Sure.
So we get x is 0. We get x is 1. And x is negative 1. But this is where those multiplicities come in. Because, again, those are important because technically it didn't just happen once. It happened more than once. So which ones have multiplicities? 1 and negative 1. So if you just want to write multiplicity of 2, multiplicity of 2. You can write times 2, whatever makes sense that can somehow show that they're going to repeat. What'd you take out in B?
0.
Yeah, x squared, so 0 is going to be twice. Ooh, this is a bad one, is it? I think I might add a typo on this one.
Yeah.
I don't think there's a factor or anything like that.
I think we can do it.
No.
We can do it. If we put our minds
I
to it,
tried and I couldn't.
we can do it.
Okay.
Jared.
All right, so there's a multiplicity of 2 here, right? All right, I am going to talk to you guys about something here because maybe we can solve this more, and I'll talk to you guys about it a little bit. I don't think we technically can, but if I know I have a 0, how can I use that to help me here? Do you guys remember that?
Put it in.
Kind of. Use what though to put it in?
Substitution.
Substitution. Nice try that.
Quadratic form.
We actually are going to use the quadratic formula today, but that's not it. That's not it here.
Distribution.
Do you guys remember if we have a 0 of a function, how can that help us to factor more?
Because we already have one more.
Put it equal to 0. That's it.
Yeah, you can do synthetic division, but I'm going to tell you guys a 0, you can do synthetic division, but I'm going to tell you a 0 is not usually very helpful with that, and I'll show you guys why. If I go to put this in, taking a 0 out, you're going to notice it doesn't really do anything.
And it's supposed to be 2.
Yeah.
What?
It's supposed to be 2.
Oh, it's supposed to be 2. It's still not going to do anything because it's 2. So nothing's going to happen. So zeros, if it was a number other than 0, we might be able to do something with it, but I think I just had a typo on this problem. So all we know about the the x is 0, multiplicity of 2, there might be other zeros there, we don't know what they are right now. You can, so someone mentioned quadratic formula. It would work nicely for quadratic formula if this was a what? What do you need for quadratic formula, do you know? No, we'll talk about it, so that'll be a good review today. Quadratic formula, it needs to be a quadratic equation, which means the highest power can only be a 2. So if it's a 3, the quadratic formula doesn't work. But nice try, we'll use that a little bit. All right.
2 more pops and we get a break.
Yes.
Can we go outside?
Yeah, I didn't bring a jacket.
It's so nice out
I
there.
got 2.
It's like 50 degrees, 60, 70, 80 degrees.
It's like
It's actually,
it's like 97.
yeah.
What's the temperature?
Close.
97.
No, it's like
90.
that's wrong. It's like 60. Don't worry,
If you
guys.
go outside, it feels like it's 90.
Yeah, does it say what it feels like outside? Yeah. Obviously.
Mine thinks that's 47 and sunny.
The wind chill is like negative 30 though.
All right.
Wait.
So
So-
that's the type of
guys, focus. Shh, focus. We have to do this, otherwise we can't go anywhere. All right.
Okay, you do the reason. Wait.
So, okay, guys, sorry. So each of these are factors. Now, the fourth power just means it repeats 4 times. You usually could just write that 4 times, but who really wants to write that 4 times? I really hope no one tried to distribute here or do anything crazy like that. So, no wonder it took you so long. Did you distribute really?
No,
Oh, okay. Oh, okay. I was hoping that you did it. I was like, no wonder you were over there
It took me
working.
so long because I was trying to do B.
Oh, yeah, we'll talk about B. All right, so this one, x minus 1 actually repeats. So x equals 1 repeats 4 times. So this one has a multiplicity of 4 because it would repeat 4 times because of that 4th power. This one, when I solve it, is going to repeat twice. Now careful on this one. This is where we get a little bit like getting into what we talked about yesterday and combining what we talked about today. Because when I go to solve this, what happens? What do? You get an imaginary solution. Because you move this 1 over, I get x squared equals -1. I go to take the square root of that, and the square root of -1 is I. But I need to include a plus or minus I, right? Because I took the square root. So I have a plus or minus I here, and this has a multiplicity of what? 5. It actually, so both of those repeat 5 times.
What are you talking about?
Because each of them repeats 5 times. Yeah.
Oh.
Yeah. So I is 5.
I didn't call you
You're
stupid.
looking at me like I was stupid.
My bad.
Yeah, so this one would have a lot of answers. All right. All right, so letter D, let's talk about that, and then we will take a break.
Yes. That's right.
So we'll take out an x squared. Well, you guys, we're not going to get a very long break, because we still have the whole backside to do.
The backside's really
That's all
short.
because of you, Garrett.
Yeah.
Yeah, it's a short one. Yeah. You can power through. What's a 15 degree?
Garrett,
I
what?
think we can round it up to 20. How about 12?
Oh my gosh. Okay,
Why can you do that?
so I get x squared equals 0. So x is going to be 0 with a multiplicity of 2. All right. Then I have x squared plus 9 equals 0. I'm going to move that 9 over. I'm going to get x squared equals -9. So when I go to take the square root, what's the square root of -9?
Plus or minus 3.
So this is where we get the I again. So plus or minus 3I. Because the square root of a negative, we just pull that I out, and then square root of 9 is 3. And we need the positive and negative, and then this one's doesn't have any multiplicity, right? This is not squared.
So
So,
just grind out.
right.
Yeah, I say let's take a break.
Me too.
Then you'll have more time for homework.
Yeah, I say
And
we do
then
that.
you don't even do homework in class, so it's an even longer break.
I did my homework yesterday.
In class?
Yes.
That's impressive for you.
Great. Good job, Garrett.
Great.
Okay.
Let's do the golden things.
Social.
All right.
Oh,
That's
So-
a compromise. for
Garrett, get
everybody.
over yourself.
Okay,
I compromised.
I don't
so,
That's a win-win.
Garrett, so if the polynomial has a degree of n, we talked about how many zeros it would have previously, and we'd say at most, like however many zeros, because of the fact that before we hadn't talked about imaginary. So if it's a degree of n, it has exactly n real or complex. So this could be also I, imaginary zeros. So if it's degree of n, that's how many zeros it has. It just, maybe before we didn't talk about that because some of them were imaginary, or some of them had multiplicity. So, I mean, understanding that, so if it has degree of 4, it's going to have 4 zeros. One of the other things we're going to mention, and we talked about this in previous sections, so if I have a value like k and it's a 0, then we can say x minus k is a factor. Because when I want to go to solve that, I move that k over to the other side. All right, so now they want us to write a polynomial if they give us the zeros. So it has a polynomial of degree of 4, and they give us zeros. But if you notice, one of the zeros repeats. So it says degree of 4 that has zeros of -1 with a multiplicity of 2, then 2 and 0. So we're going to talk about this polynomial. How can I write that now as like an equation or a factor? I'm using this idea here. Yeah, what do you think, Maria?
I would say that an x.
What do you think, Stone?
Wouldn't it just be like x plus 1 times x plus 1?
Yeah, so if our zero is -1, if I write it this way, it's going to be x minus a -1, right? It's minus whatever the zero is. So what Stone said, he said x plus 1. Now it has a multiplicity of 2, so you can write that a couple of ways. You can just write it like this. If you prefer, don't want to use extra ink, you could write it just squared. Because x plus 1, if I solve that, would give me that -1. How about the 2? X minus 2. Okay. And then just an x, because x minus 0, why would we write x minus 0? We could just write an x. So you could either put that in front, you can write it this way if you want. Now, if I was really cruel, I would tell you to FOIL this and distribute and simplify. You do not need to. You can just leave it this way. And either of them are fine with me. All right, where it gets a little bit tricky is when some of the zeros are imaginary. So this will require a little bit more kind of finagling with our factors. So our zeros in this case, they give us 4 of them. So they're all there. It's just they look a little bit different than we're used to. There's 1, 2, 3, 4 zeros. Now just be careful with the x minus the 0. So it's x minus whatever the k is. But in this case, we kind of have 2 terms there. So I don't know, let's call it g of x, it doesn't really matter. So x minus our k, yes?
I have a question on the last one.
Yeah.
Do we have to change anything that it says like degree of 4?
So it is degree of 4, right? Though? Because, yeah, this is 1, and 2. So we have it.
Okay.
It's kind of, the degree of 4 is kind of just a double check and make sure you're not missing anything, but yeah.
Okay.
Good, no, it's a good check. I mean, it's just, yeah, they have, it's technically degree of 4 because of all the x's.
Sorry.
No, you better be. No, yeah, no, it's fine. No, you're good. I'm glad you asked.
No, you're not. Well, it's just
All right. Just wasted all that time with that question. All right, so we're going to do x minus, we're going to do this 2 plus I. Now, I'm not going to expect a ton of simplifying here, but I'm going to ask you to do a little bit. And then x minus 2 minus I. Then here, it's going to be x minus a -1, so x plus 1, and then x minus 1. Are you okay with my factors there? Now, we don't see polynomials with i's in them. So we are going to try and simplify. Well, actually, now that yeah, we're gonna try and simplify these two. We're gonna try and combine those and see if we can kind of simplify them down a little bit. So I'm distributing this negative in. Same thing here. These I can just leave. I can keep bringing them down if you want. We can rewrite them at the end. All right, this can be a little bit of a pain. I'm warning you ahead of time. We have to FOIL that, but it's 3 terms by 3 terms. So I've done the first 2 terms already. I should probably change colors so you guys can see what I'm up to here. But and stop me if I'm doing something wrong. Let me know if you see a mistake. And then now I have to do the I. The good news is with this, a whole bunch will cancel. Becomes +1, so this is 5. Again, I will not make you FOIL this whole thing, but getting rid of those i's, this is truly a polynomial versus if I left i's in there, kind of a strange circumstance there. Questions? All right, so we'll look at these last couple of examples. We'll bust through them so you guys can have time to work. Sorry, Garrett. Bless you.
Look over it.
It's the third. Not bless you on the third one. It's too much. All right. So in example 3, this is the type of problem where if you try to factor this, unless I wrote something wrong, it should not be factorable. There's no way to multiply to get 5, but add to get -4. So we have to use another method to solve this, because not everything is factorable.
What about
No.
-5? That doesn't work.
That won't multiply to give you a
Oh,
positive
yeah.
5. I know, and that's the thing, it gets so close that you're like, no, I have to make it work, but it's very likely that if you just came up with your own numbers, it's not gonna be factorable. So this is where we either have to use the quadratic formula or completing the square. I think most people are more comfortable with the quadratic formula once you're reminded of it, unless you're amazing at completing the square. So I can review that another day. I'm not going to do that today.
Okay.
We'll do quadratic formula today. I can review completing the square with you guys another time. And I could do it on the board over here, but I want to get us through notes here. So quadratic formula is a big ugly formula. However, it's just plugging numbers in and simplifying. And you guys are pretty good at that. I mean, I know that that's something that you can handle. So, since we can't factor this, quadratic formula works very nicely. Now, even if you didn't like factoring at all, quadratic formula works. So this is kind of a nice one to kind of fall back on. And where these numbers come from is just the equation when it's in standard form. So our A is 1, our B is -4, our C is 5. I'm going to put all this in. So -4 becomes +4, opposite of B. You guys, I know you've seen this before, it might have been a while, but then I have -4 squared minus 4 times A times C all over 2 times A. So if you're ever stuck, you can't factor, or you just can't find the factors, quadratic formula works nicely. However, this one's kind of a strange one. (16 minus 20 is how much? -4. Now if I go to take the square root of a -4, what do I get? 2i. So again, quadratic formula works really nicely because of the fact that it actually deals with imaginary numbers pretty nicely, whereas factoring, we don't know how to factor with imaginary numbers. So -4 is just 2i. Can I divide those both by 2? Yep, so 2 plus or minus I would be our solutions for this. So we get 2 answers, 2 plus I and 2 minus I would be our solutions. I put this in there because I believe there's one problem in our homework that you need quadratic formula for. So our homework is not super long, and so when you need this, hopefully it won't be too overwhelming, but if you can't factor, quadratic formula works well. All right, so this is getting us back to what I was trying to do, I think, in like letter B back up there. If I know -1 is a 0, the following, it asks us to find all the zeros. So this is where we want to use synthetic division, or synthetic division to kind of get the rest of this out. Because if I try to factor this, this isn't factorable at this point. And so we'll see if we can get that out of there and help us out here. So -1 is a 0, so I don't have to change anything about it. I take all our coefficients. And multiply. And multiply. So what I'm left with is I'm left with x squared minus 10x plus 29. Does 29 have any factors? No. It's a prime number. So this would be a case where now we put ourselves into quadratic formula. Unless you wanted me to show you completing the square. I'm going to stick with just one today. All right. Finish this up. So opposite of B, square root of -16. divide those each by 2. So these would be our other 2 answers based off of knowing that -1 was also a solution. So if I wanted to know all the zeros, this is 2 answers, and then this is our other. 2 of them are imaginary, 1 is real.